So in my talk, I will tell basically the story that how we successfully run away from legacy code. Um, a big introduction from me. Yeah, my name is Thach, but people also call me Rooney. It was common. I'm started using Go since 2015 or something, or earlier, and become Vietnam organizer. It's also I also have my day job as engineer manager at B. So so exactly B? So B is a ride-hailing system that you can compare with some kind of GoVid or Grab or Uber. So we just celebrate the first zero birthday. We have about 20 plus products like transportation, delivery, food, and trade payment. We have about 100K drivers, 3 million users, about 100 microservices, and 200,000 booking a day. We consider as the fastest growth rate in Asia 2018, according to a paper from Korea. So the funny thing is B is 1 year old, but we also receive from the legacy code. We do have legacy code from the previous team. So what exactly is legacy code? Legacy code is somehow you receive a code inherited by the team or programmer that somewhere else you don't know. The code that make you sad, make you upset, you say bad things when you're reading it. Sometimes it was good code that you just don't understand and don't know why there. And sometimes it's your code, just why you have no idea why you have written it. Forget it. So how bad were we? I mean, our legacy code is we have about 300, we have about 700K live code base, a single monolithic few services. We have a file that about 16K live code that, when I open with my Vim is frozen and it crashed. 2000 live code functionality that call end ride when you end a transportation ride. And there's no way to read it. It has about 4 generations of engineer, like the first class engineer wrote it, and run away. The next come, finish it, add some new features, and we are at the 4. It has a free code style, no comments, no documentations, and of course no tests. About the database call, we have a single sort to plain SQL. There is no RM. That's painful. And it's written in NodeJS, and it has callbacks. There is not something better like a single way or promise or something. It's just a callback, and it had callback hell. It's about 10 levels, and when you're missing some kind of bracket or something you lost, you fuck. The beautiful thing of legacy, it just works. That means legacy means the code is working. But the just here is just barely work. When we run this legacy code in production in the December, as Jay said, we have in 6 months, very first 6 months, we had about 40 incidents in different kinds of incidents. Downtime from 5 minutes to 2 hours, many kinds. So what is the reason? I mean, some of the reason is from performance. So we have a big database, right? There is no index. Some table has no index. Some table over-indexing, like multiple column indexing. We have excessive database calls. A database has about 1,000 tables, and some table has about 100 plus columns. And because of the MySQL has a functionality that cross database zones, and so there's no way to distribute to scale horizontally by separate the database. We have just a big one and just scale vertically. Or the error handling. And you can see the arrow here. There is no track. So what if some kind of fail in calling the database? And the error is not new. So but there's no handle. So it's passed to the noun data in the previous call, and it could crash or strange behavior that we don't know. or typically is a memlink that you can see the SQL, the SQL driver like before, this variable. The thing is there is no var or no let, and it's become the scope of global, and that means it's never be GC'd. And over time, it calls memlink. Or no catching, that is called only plain SQL call. So when we scale about 10 is in 1 month, it crashes our CPU, it makes our CPU overload. So the thing is, we survive. In first 6 months, we try everything, we face, and it works. So how about journey? So the rule of thumb that when we working with the legacy code is legacy code try to make it friend is not your enemy. Or if you think it's an enemy, try to make it close. I mean, keep it close. Don't try to love it. Try to make friend with it. Is the way that mitigate one enemy and make new friend. So don't complain if you don't intend to improve code. I keep telling my team that stop blaming. That's why. And if you don't try to make something better, don't try to refactor the code. Stop complaining. And as long as you touch the code, it's your code. It's not legacy code anymore. It's your code. So it's a history, commit everything, right? When you change something, you add a line, you refactor something, it's your code now, not the legacy code anymore. And don't try to fix something in blind. I mean, try to observe the full flow, add some metrics, and observe the result. Approaching. So don't try to jump. I mean, when you read the legacy code, I met some guy that he say he spent all day for reading the legacy code. I mean, the whole code base, but that makes no sense. So before you run into the legacy code, for example, you try to understand something happened. Try to design by yourself. Like we have some function called start right? So if we do that, how we do? I mean, you have to design by yourself, and then we jump to the legacy code and compare it with your design, and it's much better. It's much better in understanding. So be confident that when deleting any code, that you think that this never be rich or unused, or simply that you have no idea is why it's there, it's here, and you don't understand. Don't let it grow. That means write no more code legacy. Try to separate or new service, write new code. Start small. I mean, migrate partially, try a new one. Small but grow better, incrementally. So B has the migrating plan. We choose the microservice architecture, event-driven. Anything, I mean, every new code, every new services, every new feature, we try to explore by write a new service and no touching the legacy code. We try to choose a better language, stay away from NodeJS. As you can see, I can spend all day to blame NodeJS or something, but yeah, try to choose a better language. And because we need to scale, we are labeled. Compared to Grab or something, we need to set up standard that we can scale a team. Scale team is somehow more important, or the same important with the scale your system. So we choose Go. Let's go. So why? Because it's Go conference, right? Everybody using Go, so there's quite transparent, it's fast. Readability, documentation is no fancy. This focus on productivity. The learning curve is very slow. I mean, very low. Low cost to pay. It's just about 2 weeks or 3 weeks that you can code in production. It had a great OS system. A lot of practice you have to learn from. Yeah, and it incorporates extremely well that with the cloud native and DevOps, you can see a lot of tools that written in Go, like Docker, Kubernetes, a lot of great things. a bit stack. So basically, it is a simple request, right? The users in mobile, we basically mostly is using mobile, using RESTful API, and we reserve something called gRPC gateway to as a reverse proxy. gRPC has some drawback, but at the moment it's still acceptable, so we use it to reversely convert from JSON to gRPC, RESTful to a gRPC call, and we serve internally 100% gRPC in internal service. About the cloud native stack, that yeah, a lot of buzzwords there. Docker, ham install, doc, driver and Prometheus, gRPC. Yeah, we're all there. We have some pressure about the scale that, as I mentioned before, we are just 1 year old. And the grab is start from 2013. Same Uber, GoVid, they have a history of, engineer that the team is really big and powerful. So we under pressure. We have about 20 plus ongoing products. We have a diversity team location, the team in Hanoi, the team in Ho Chi Minh City, the team in Singapore. And we have pressure of, we have to grow 3x for now engineers to serve the products. And scale always have some drawbacks. It's extremely high cost from the ops, the DevOps, like you have to monitor a lot, you have, well, the drawback of microservice overhead is about the ops, not the code. Because of diversity team, so each team has its own way to code, like they decide by themselves this architecture, TDD, DDD, or tree tails or something. They decide by themselves, not follow any convention. And the thing is, still not everyone knows Go, and we find very many difficulties when hiring Go, because the Go community is not really big in Vietnam. So let me introduce you the tool that we use to, massive deploy and massive scale our team. It's called BEGROUP. Yeah, that's one. I think that's not the right mascot for Go, but yeah, it's cute. So what exactly is BEGROUP? BEGROUP is a kit. Kit is somehow a tool that you use to do something, right? And it's born to have engineers that about 5 minutes to deploy any service, new service to production. Yeah. And yeah, it has some functionality. It has some utilities that have the performance of the engineer faster. It means you don't need to do a lot of handy things, configuration or something. And yeah, it end-to-end standardization. That means I will make the team that all use of it. And when you jump from service to service, you understand the structure, the same code base, the same architecture, and it's easily to scale, easily to maintain. There's some principle in the BEGROUP that we design. So it's convention over configurations, like, yeah, it's really common, right? Instead of you configure something, you just, hey, this file should be followed by the gen surface or something, and it's make it better. You just write some documentation and don't need to configure it. And let everything be generated. That means what can be generated, just make it generated. The less human bugs, the less human touching, that means less error prone. Simple, runnable, get things done, of course. The typical design a very small service. I will show you later. And the last but not least is trying to stay away from network concerns. And you can see the service-to-service communication has had a lot of things like service recovery, like circuit breaker, relimiting, a lot of. So if you try to implement yourself, that means you have to inject to the code that you have to add the middleware of relimit, you have to add the middleware of circuit breaking. We will handle it, all the things. DevOps concern, you have no idea. Just focus on the business logic. So about the technologies behind is, yeah, quite simple. Templates, HT, parsers, struct manipulating by, we use a library of the Fatil, Go contributor, and we use BEGROUP with a really interesting, useful product from Holistic. So how we massive rolling out? So we just force, because we are the first man created, force by command. And every newcomer we will onboarding, I will train them to use the BKit at every new service. And what? When we build the culture that BKit should be crowd contribution, that means there's a toolkit that for team, right? Everybody should use it and try to make it better by submit pull requests or something, contribute. It's called crowd contribution. Some achievement. We have 40 services created and launched into production by using BKit in 6 months. 100% engineers default bootstrapping tool. That means when you, top of mind, when you try to create a new service, you use BKit. 10 contributors. That means engineer use it and give feedback and make it better. 50% development speed, just approximately, but I think that because by remove handy function, that means, it quite boosts the development speed a lot. So I will have a quick demo. So you guys can see it, okay? So I try to bootstrapping try to bootstrap the service called BEGROUP. This is command, right? Bootstrap create with the name is BEGROUP. We use the database is MySQL. It's took about 30 seconds if the network connectivity is well. There's the most heavy thing, creating vendor. It has a download thing. How long does it take? Is about 36 to 48. Yeah, it's more than 1 minute because of network connectivity, I think. So we have a BEGROUP service, a new service. So what exactly inside? So you can see it's quite common. We decide by ourselves, like CMD, the server clients for test, the server for run demand.go, the configuration, documents. We automatically generate the documents by the Swagger, the gRPC generator. We have internal that has models, 3 tiers, model, service, store, typically. We have PP, the proto, and vendor. Yeah, where some kind of Jenkins files and Make files and Docker files for you when you just pushing your service into the Zig repository, it automatically deploy in 3 environment: dev, staging, and productions. Production is manually. Trying to run it. Okay, it's work. So it has a default, handler for health checking. If you understand, if you're working with the KAS, it has some kind of liveness and readiness, and it is health endpoint, and it's okay. That means the Kubernetes can polling can polling the API and check this service is healthy. So as a next, I will like an engineer. So I want to design this service, right? So we think that the most painful thing in design a service is from the design of database. So if you design database is good enough, that how bad your code is still acceptable. But if you design somehow your database is bad, that how good your code is, how you're trying to write best code or something is still bad. So we use some kind of DB diagram tools there. If no one knows that the DB diagram is the product of holistic that is used for drawing the diagram, the UML diagram. So I will create some more like a company table. It has 3 attributes. The ID should be auto increment, the name and the address. So I save it. So I will try to import this diagram into our model, right? So I just run. There. We should just run the import from the URL that from diagram, and it automatically generate the model correspondingly. And you see it has two models, company and users. Okay, let's see. There, the companies and the user. Okay, the next thing I will try to write an API handler for this, like try to create a company, right? So I just need to jump to service portal. I will write some functionality RBC, like create company, something like that. Okay, so I will create a company file portal, right? It has a message of company. It has request as company request, receive a company, return a response. The ID just generated. Okay, when I run Mac generate, it create, from the proto file, and it also create some kind of gRPC gateway, gRPC documentation. It's a worker, and we use this input to API docs. So I will implement this by, so the service inside the Go should be implement this function, this create company function, right? So I need to use the Picket. So I just need to add a comment here. Service company. And try to run Picket service implement. So it's Zen two file. The first one is a company, and the second one is a company Zen. Why is my functionality? Service company. Just wait me for a second. I don't know what happening. Sorry, I'm so nervous that I cannot find what's going on, but so I will show the demo from the video that I already prepared earlier. But actually, I don't know why. So when we run to the service element, like this, there, when we run some kind of service element, it creates some a generated file like user and user plus gen surface, and the user.gen, that means you cannot override it. So you just only need override the user.go. In there, I will create a model.users, import the username, try to use a user store, and save. The thing is that the store is also automatically generated, like when we import. Yeah, you can see it creates some store. Store is the one that you manipulate with the database, and it automatically, generate the common function like save, get by ID, or update, some maybe delete. And the bad things of using some layer is dependency injection is really, sometimes you have to sometimes you forgot your dependency injection. But the Bkit in the generator, it automatically inject your store in any layer of creation constructor, like the service. It automatically create to store and inject to the new function. The same with the main layer. There. Continue the video. So we try to save the user. Try to run it. Yeah, it's a typo in the file. Yeah, I try to send a post request to create a user with the new ID. Yeah. So all this process is about 5 minutes. That when you bootstrapping the service, you create a API handler, you create a store, model, add some field. It's just about 5 minutes, and you can have a runnable service introductions with your API handler. In the roadmap, we have we add some kind of like end-to-end testing, like service of service. We already have a gRPC. The message request. So we just generate it. When the service A calls service B, we can have a test functionality by generated code, or we have some kind of mapping, like when you write a model and you need to map with the bottom-up message, right? Somehow you add on one more column, but you forget to add the mapping. The Bkit can do it for you. So this is all the way that we make everything better when the way that migrating from the legacy code to the new code. The drawback of legacy code is bad. This painful to read, is tough, it's hard, but it's worth it. Just look back for the 40 incident that we make, that we think that we learn a lot from it, we mature a lot. So I just think that what doesn't kill you, and that just make you stronger, and legacy is one of the part of it. This is all for my talk. Thank you for listening.